This interview is with Professor Andrew Cameron, an astrophysicist at St Andrews. We discuss his research and its impact, what academia has taught him about travelling, and about his favourite science communicator and dreams coming true. Enjoy listening. You're listening to Insight, the University of St Andrews Student Physics Society's podcast. I'm your host, Samuel Avery. Join us as we journey into the lives of St Andrews academics, discovering their passions, inspirations, and motivations. Today on Insight, we're interviewing Professor Andrew Cameron, an astrophysicist here at the university. And welcome back, because we've actually had you on before, reading Little Red Riding Hood from Roald Dahl's Revolting Rounds for our winter special. So thanks again for joining us.
No worries.
So, first things first, could you tell us your positions here at St Andrews?
Well, I was first hired here in 1994 from a lectureship at Sussex to a readership here at St Andrews. And I've been here ever since and made it to professor, I think after 4 attempts at promotion in, I think, about 2002.
Try again. And what path led you to your position here at St Andrews then?
Well, as a kid, I was interested in astronomy. I studied physics in high school and then did an undergraduate degree in physics at the University of Canterbury in New Zealand, followed by a PhD in astronomy. I'd been interested in astronomy since I was a kid, and so I picked the only university in New Zealand that actually had astronomy as part of the degree. In the end, I was the second person to do a PhD in astronomy in New Zealand without actually leaving the country first. So when I finished, there wasn't a lot in the way of job opportunities in New Zealand, so I bought myself a one-way ticket out of New Zealand, wrote a lot of job applications, and finished up at the Royal Greenwich Observatory as a postdoc. In those days it was sited, well, in those days it existed, and it was sited down at Hurstmonceux on the south coast of England, near Eastbourne. So I did a postdoc there for 2 years, got a second postdoctoral position working for Donald Lyndon Bell in Cambridge. I was there for about 2.5 years, and then got a postdoc down at Sussex working with Professor Leon Mestel. And a couple of years after that, managed to get an advanced fellowship, which led to the offer of a lectureship a year or so later. And when my fellowship ran out, I started as a lecturer at Sussex. I think I did 1 semester there before I got the job up here. And here I am today.
Only 1 semester, that's very short. And you've obviously done a lot of following your passion then, with all that travelling about.
A lot.
The one-way ticket, wow. Can you tell us a bit about your research here then?
Yes.
Or elsewhere, yeah.
Well, when I first came here, the first exoplanet hadn't been discovered yet. Or at least one had, but it hadn't been recognised as such. So the big discovery was in 1995, but up till that point I had been working on the equivalent of solar magnetic activity on other stars, but from an observational perspective. And in particular, I had met another postdoc down at Cambridge, somebody by the name of Keith Horn, who was interested in astronomical tomography. He was busy mapping the surface brightnesses and temperatures of accretion disks and suggested that it might work also for measuring the surface brightness distributions on stellar surfaces. So I got into maximum entropy imaging of stellar surfaces and spent the better part of a decade mapping the locations of star spots and also differential rotation patterns on young, rapidly rotating stars. So that was pretty exciting stuff, but it turned out that when exoplanets came along, some of the techniques that we were using were actually transplantable into the new field, and so I gradually moved into exoplanets.
So as a field was discovered, you basically were able to become a leader in that field, despite it being brand new.
It was a good opportunity, and in fact, a lot of people who had been working in high-resolution spectroscopy of cool stars had all of the technical skills that were needed for high precision radial velocity work. And a lot of people from the cool stars community formed the first generation of exoplanet researchers.
So in studying exoplanets, these planets around other stars, you must consider the possibility of extraterrestrial life often enough. Do you commit to believing in that, or?
I think it would be very hard to avoid, given that the things that we're made out of, the things that are most critical to our existence, like carbon, nitrogen, oxygen, all the various elements that are formed in the most common thermonuclear reactions in stars, they're very abundant in the universe.
So you have to go with the statistics on this one.
I have to go with the statistics on that one.
Do you have a favourite thing in your field of research? A favourite phenomenon or a favourite star?
Favourite thing? Well, I guess if I have a favourite star, it's probably a star in the direction of the Large Magellanic Cloud called AB Doradus.
Catchy.
AB Doradus is about 100 million years old. It spins on its axis every 12.5 hours. And the only time of year when we used to be able to get enough time on the Anglo-Australian telescope to be able to map its surface was by volunteering for the Christmas New Year run. So for many years during the AB Dor mapping campaign, I had my Christmas dinner in the Chinese restaurant in Coonabarabran with the rest of the team. Developed a great taste for Mongolian lamb. And in fact, the project was called to a brutal halt when my kids were eventually old enough to realize that Christmas was not on December the 17th. So yeah, AB Dor is my favorite star.
That sounds a fun one with Mongolian lamb. That sounds.
Oh yeah, fine stuff.
So, do you use simulations in your work?
I do. I've been using a simulation recently of the entire population of hot Jupiters. After, let me see, how long ago did we start the WASP project? We made our first discoveries about 11 years ago. And WASP and HAT and all the various other ground-based exoplanet transit surveys have together produced something like 200 or 300 exoplanet systems, which is actually a big enough population that we can start to do population statistics on them. And one of the interesting things you can do with these giant exoplanets that are orbiting very close to their host stars is plot their masses against their separation from the host star. And you find that there is a complete lack of massive, very close-in exoplanets. And the theory behind why that should be happening is that the planets are raising tidal bulges on their stars. The stars are slowly rotating, the planets are going around faster, so it's the reverse of the Earth-Moon system. Instead of the planet spiraling away from the star, it spirals towards the star, but it doesn't have enough angular momentum to spin up the star to synchronous rotation, so eventually it'll get destroyed. The thing that's uncertain by a factor of 1,000 is how strong that tidal interaction is. So one of the things that Moira Jardin and I have been working on is simulating the population of hot Jupiters under different assumptions, and then about the strength of the tidal interaction, and then using what's known as hierarchical Bayesian inference to back out the strength of the tidal interaction from those simulations. And it turns out that it works beautifully. You can determine the strength of the interaction to within about a factor of 2, which is a considerable improvement on an uncertainty of a factor of 1,000. And anyway, we got that paper published in January this year. So yeah, I use simulations.
So obviously you're able to get stuff done with the simulations then, but do you find the factor of 1,000 uncertainty that you mentioned, do you find this uncertainty in your work quite frustrating to deal with? Is it? Well,
I found it annoying enough to do the simulations that cooked it down to a factor of 2. And that I find more satisfying.
That does make sense. So astrophysics does have a bit of a stigma for being associated with large uncertainties. Do you think that's deserved, or?
Well, I mean, it's a very big field, and these things are a long way away. But when you have an important piece of physics whose manifestations are uncertain by such a large amount, that actually, for most scientists, is like a red rag to a bull. It's a very strong motivation for launching a research effort to try and improve matters.
Okay, and you've mentioned that's one motivation, but I was going to say you've got over 370 research publications to your name. So what is it that keeps driving you? Are you desperate to find another planet we can escape to, or do you want to get off Earth?
No, I just have the good fortune to work in very large teams of talented young people who have far more time than I do to write papers. Yes, I do have a great publication rate, but it's usually as a co-author. And by the time you're involved in the senior management of very large projects like WASP or some of the space missions I'm involved in, there are huge numbers of people involved, and so there's a great multiplying factor in the output of publications. But for instance, take the HARPS North project as an example. HARPS North is a high-precision spectrograph designed for measuring stellar wobbles and deducing the masses of what we call super-Earths, which are planets that are seen in transit against their host stars, producing dips in light that indicate the planet is a bit bigger than the Earth. And if we can weigh them, then we can measure their densities and hence make a guess at what their interior composition is. So we're looking to see whether these things are predominantly rocky or icy. It's painstaking work. It takes about 50 to 100 hours on a 4-meter telescope in order to get a mass determination that's good to about 1 part in 6. But we've done about a dozen of them in the last 5 years, and that represents about 60% of the mass determinations that have been done for super-Earths so far. So it's not easy, but it's challenging and it's fun, and they're the nearest thing to Earth mass rocky planets that we can study at the moment.
Okay, so you've just mentioned as well that impressive statistic, 60% of these determinations. But you've also mentioned that you've done a lot of collaborative effort, so I was wondering if there's anything particularly rewarding about completing projects across many institutions.
It's very good for the papers that come out, because it means that although you have a large authorship list, that's actually an advantage, because before the paper goes off to the journal, it gets run past many people with different expertise. So you gain a whole lot of perspectives on many, many facets of the research that goes into the paper. And exoplanet discovery papers are notorious for the number of different bits of physics that are actually involved. You have to analyze the transit, which means understanding the atmosphere of the star and the brightness variations of the star from its middle to its edge. You have to understand all the systematics involved in measuring the radial velocities and even stellar magnetic activity, because that's the main confusing factor that we're up against when you're trying to measure tiny stellar Doppler shifts caused by reflex motions with speeds of around 2 meters per second. That's walking pace, folks. We can measure the velocity of a star going at walking pace.
That's quite impressive. So it's really having all this expertise from so many different areas that you can draw upon.
Yeah, it's hugely important for this large team-based science.
Okay. So I was wanting to ask some questions about fieldwork. So what's the most exotic location that you've traveled to for astronomical purposes? Not on holiday necessarily, but for academic or for pleasure if you're going stargazing.
In January 2003, I had the good fortune to be allocated some time on the 8-meter Unit 2 telescope of the VLT at Paranal in Chile. So I travelled out to Antofagasta in Chile, which I think is the driest place that I have ever seen on Earth. Next day, no, in fact, it was the day of arrival. Took a jeep out into the desert. It was a couple of hours' drive into the seaward range of pink hills with blue sky above. strewn with rocks, the occasional one of which had been painted as a frog or a Nike shoe. But apart from that, it could have been Mars. And indeed, they used to test a lot of the Mars rovers there. But eventually, when we arrived at the observatory, there was a low dome and a ramp leading down underneath it. And so I walked down the ramp through two very heavy steel doors and straight into what I thought looked exactly like the baddie's base in a James Bond movie. It was about 3 stories deep with a dome over the top, a hillside with a banana plantation on it sloping down to a swimming pool at the bottom. And all this in the middle of the driest desert on Earth.
Wow.
And in fact, so that is the residencia at Paranal. And in fact, I was absolutely right about it being the base for a James Bond movie. It was used as the set for A Quantum of Solace a few years later.
Oh, wow. Fantastic. That's amazing. So would you say that you found the most beautiful or inspiring night sky there then, when you travelled there to this?
No. The most beautiful and inspiring night sky I have ever seen is where I grew up, about 20 miles out of Nelson in New Zealand, on an apple orchard on a tidal estuary, well away from city lights. And in the summer, you could see the Magellanic Clouds, our 2 satellite galaxies, absolutely clearly. It's a beautifully dark sky. In August, the centre of the galaxy was straight overhead. And when I was about 11, 12 years old, I developed an interest in astrophotography using 400 ASA film. I had the good fortune that the guy who owned the local deli with his brother and sister was somebody by the name of Albert Jones, who by coincidence turned out to be the world's most prolific amateur variable star observer. And so he was my mentor as an amateur astronomer, and advised me on things like what sort of drive to get for a small telescope that I could mount the camera piggyback on to do astrophotography. So, yes, I did a lot of photography of the galactic center and the Magellanic Clouds and all the lovely skies that you get well away from city lights in the southern hemisphere.
Fantastic. And that's quite the amazing coincidence then as well. Wow. So what's something that travelling for academia has taught you about travel, academia worldwide, or just different countries in general?
Travel light.
Travel light.
Yeah. You never need more than a backpack for 2 days' changes of clothes. Anything further than that, if it'll fit in the overhead rack on the aircraft, do it. Because if you're travelling from Scotland and you need to change planes somewhere, they will lose your baggage if you put it in the hold.
Okay, noted. And what's one thing that any astronomer should bring out when they're doing observing?
Oh, goodness. I would say one of those blackout eye masks so that you can sleep during the day.
That sounds solid advice. Do you have a perfect hot chocolate or hot beverage for whilst you're doing fieldwork or while you're at home?
Oh, actually, I discovered a really nice coffee. Oh, what was it called? I think it was Mount Etna. That they were selling it at the Balgove Larder the other day. It's a number 6, but it's got a lovely dark chocolatey taste to it.
It's coffee?
It's a coffee, yeah. Good stuff.
Excellent. So, do you have any notable stories that you can tell us from either your student days or your teaching days?
Too many to remember, but there's one that sticks in my mind, which is when I was at Mount John. This was the observatory of the University of Canterbury, which is down on Lake Tekapo in the South Island of New Zealand. I used to go down there observing for about a week each month. And my office mate back in Christchurch, Steve Mackwell, was down there. We were observing one April. And we thought, oh, it's April the 1st. So we sent a message. We must have sent it by telex, I think, because we didn't have email in those days, to my PhD supervisor, John Hernshaw, saying, have you seen there's been a supernova in the Large Magellanic Cloud? Now, this was, I should add, about 1980. we did our calculations. We figured out how bright it ought to be. John, of course, got immensely excited and started issuing instructions as to which instrument changes we should do on the telescope to get spectra and photometry of this thing. So we let him rant on for about half an hour before we pointed out that it was April the 1st. The irony is, of course, that 7 years later, a real supernova went off in the Large Magellanic Cloud. The famous supernova 1987A, which yielded neutrino detections and all sorts of things, and which, in fact, I think is probably the most impressive object I have ever seen in the sky.
Oh, wow.
With one exception. But, it was incredible. It was about third magnitude, which makes it about the brightness of the stars in Orion's belt, but deep, deep red. And it outshone its entire host galaxy.
Wow.
And I saw it. I was on an observing run at the Anglo-Australian telescope. I think it was in March, April, so it was a month or two after it had gone off when it was more or less at its brightest. And it really was. I mean, it was the first naked eye supernova in 400 years, so I felt incredibly privileged to have been able to get to the southern hemisphere in time to see it. Ironically enough, the second person to see it by eye and to notice that there was something wrong with the Magellanic Cloud was none other than Albert Jones. My mentor back in Nelson. The only person who beat him to it was one of the telescope operators at Las Campanas. But they had the advantage of longitude. But Albert spotted straight away that there was a star in the Large Magellanic Cloud that shouldn't be there.
That's a keen eye.
He was that sort of person, you know.
Wow. So is there anything that you miss particularly from your student days then? Is it April Fool's pranks?
Oh, there's lots of things that I miss. But I think probably the thing I miss most is the time to have long periods of unbroken concentration on a problem. On the other hand, I've learnt to live with shorter periods of concentration and to help other people direct their own unbroken periods of concentration in the right direction. So, but yeah, it was fun being a student.
Agreed. If you weren't working in astrophysics, what would you be doing?
I think if I had to switch careers today, I would be extremely interested in pursuing a career in data science. We're increasingly using machine learning techniques in the sort of signal processing that we do in exoplanetary science. And the way some of these algorithms like Markov chain Monte Carlo or Gaussian process regression seem to take on lives of their own is truly remarkable. And I get a tremendous buzz from just watching them apparently solve problems effortlessly on their own.
Neat. What's something that you're particularly proud of having completed or achieved?
I think I've written a few computer codes in my life. I was particularly proud of the Doppler imaging code that I wrote, which yielded images of the star spot distributions on the surfaces of rotating stars, reconstructed from line profiles in spectroscopy. But I think the thing that probably takes the biscuit is the data analysis pipeline for the WASP project, which took me 2.5 years locked up in my office to write and then to hand on to my team of postdocs who took my bad code and made it bulletproof. But it's been running at Belfast and at Kiel and more recently at Warwick. For the last 12 years, it's processed something like 3 × 10⁻12 data points.
So a considerable amount then.
Without falling over.
That's a very impressive piece of code, yeah.
Yep, and it's led to the discovery of about 170 exoplanets.
Which not everyone can claim being part of. Wow, that is phenomenal. So moving on to another topic. Is there something that you wish that you'd learned or have done by now? Not necessarily in academia.
I wish I had learned sooner to delegate fun more effectively. There's always a danger in science of being selfish and wanting to hang on to the fun part, which is the legwork of the early stages of a project. I think I was very bad as a PhD supervisor in my early years at grabbing the steering wheel too soon. I learned not to do that when I was head of school. I didn't have time. And I think, ironically enough, it was actually very good for me in that respect. But now I think it's, I can derive a lot of satisfaction from doing what an advisor is supposed to do, which is advising.
Okay, character growth.
Character growth, yes.
So, do you have a favourite hobby?
Do I have a favourite hobby? Yes, photography. So from those early days of astrophotography in New Zealand, I also used to paint as well. Haven't had so much time for that in recent years, but it's grown into a love of landscape photography and underwater photography, and anything that involves a camera is good fun.
You should try do an exhibition in the physics building someday.
Oh, there's a scary prospect for you.
I'm sure it'd be fantastic. Do you have a favourite sport or team?
I am a third-generation skier. My mother was a ski racer, and it rubbed off. And all Moira's and my kids are skiers too. Moira wasn't a skier when I first met her. Funnily enough, she still kept it up, even though the first time I took her skiing, she broke her leg at the end of the week. She's not the sort of person to be put off by that kind of thing.
It's very encouraging.
My daughter Natalie also broke her leg this last Christmas, doing the same thing. And I broke my leg when I was about 12, so three out of the five of us have been carried down the mountain in a blood wagon. So
fun, but slightly dangerous then.
I mean, it's a low probability event. I mean, I've been skiing for what?
It's only 3 in every 5 skiers.
Half a century, and I've only injured myself seriously once.
That's fair enough. Seems like good stats. How many languages do you speak?
I speak English, sort of, and a little bit of French.
And do you wish that you knew any more?
I do. Yes. In particular, I wish that I'd learnt Spanish, because most of the world's observatories are on Spanish-speaking territory, and I keep promising myself that I'm going to do it, and it never quite gets beyond the restaurant menu.
I mean, it gets easier to put off with more like Google Translate, doesn't it?
It does, yeah. Yes, I have found myself using Google Translate, particularly its voice recognition capabilities, a lot more recently when in dire circumstances. It's quite useful when dealing with the French medical system, for example.
Oh dear. So we're going to move on to some quickfire questions, so you can take time to explain your answers, but we'll try and get through them a bit quicker. So what's your favourite music genre, and do you have a favourite song? I
grew up in the 70s, so it's 70s rock.
That's a solid choice.
Yeah.
And do you have a favourite song from 70s rock?
Yes. Comfortably Numb by Pink Floyd.
There is no pain, you are receding. A distant ship, smoke on the horizon. You are only coming through in waves. Your lips move, but I can't hear what you're saying.
Excellent. And do you have a favourite non-academic book?
Yes. I would say that the book that I have read most often throughout my life since childhood would be Arthur C. Clarke's 2001. The paper version, not the cinematic version. But in recent years, my preferences have drifted more towards the works of Ian Banks, whose culture novels, to me, are a fascinating and often gory and horrible, but also extremely funny portrait of the ultimate socialist utopia run by benign artificial intelligences. Or at least they might be benign. You're never quite entirely sure. But I think among those novels, my favourite would be Accession, which really gives most prominence to the machine entities that run the ginormous vessels that are essentially the home of the culture.
So firmly rooted in sci-fi there.
Absolutely.
What is your favourite type of food? Is it Mongolian?
I've never actually tried to cook Mongolian lamb, but I do enjoy anything that can be made in a wok. There's something very satisfying about a good stir fry.
That is a good choice, yes. And what's the nerdiest or geekiest thing that you love? Sci-fi novels, maybe? You're a die-hard Star Trek fan at home, or...
Die-hard Star Trek fan.
Die-hard Star Trek fan.
Die-hard Star Trek fan, yeah.
Okay.
No, I've actually been enjoying the new series, Discovery, which is a very much darker take on the whole Star Trek universe than we've seen in previous series, but it's...
But it is good.
It is very good.
And the special effects are astounding.
The interesting thing about it is that the story, I think possibly for the first time in Star Trek, the script writing actually outshines the special effects. I'm very, very impressed with the tale that they've constructed and the levels of complexity in the whole thing. It really... Okay, we're on nerdy here. So Moira and I watched it through twice, just to make sure that we picked up all the stuff that we'd missed out.
Were you binge watching it, or were you? Was it?
Yes, we were binge watching it.
Excellent. So die-hard Star Trek fan, and maybe Star Trek Discovery more recently.
Definitely, yeah.
That's a good answer.
I grew up on Kirk and Spock.
What superpower would you have?
Oh, I often dream about flying.
How, like within Earth's atmosphere, or would you want to fly out to the stars?
Oh, I'd be perfectly content with being able to fly up to the top shelf at the supermarket and get bottles off it. But no, I don't think I'd want to go too high. Ikaros tried that and got into an awful lot of trouble.
That is true. Do you have a favourite science communicator?
That would have to be Patrick Moore. I grew up on his books. I learnt everything that I knew about astronomy until I got to university from reading the collected works of Patrick Moore. And in fact, one of my proudest moments was actually being interviewed by Patrick on the Sky at Night back in 2006, just after we'd discovered WASP-1 and WASP-2. So I found out how the Sky at Night worked from the inside, all the way from the Friday night chili to the observing session in the garden on the Saturday night. It was quite a well-rehearsed monthly ritual with Patrick.
Dreams do come true then.
Absolutely. I mean, I couldn't believe it. You know, as a kid who'd grown up in the back blocks of New Zealand reading his books, to finish up on his TV show in the UK just seemed extraordinary.
That is amazing. Do you have a favourite country to observe in?
South America has superb instruments and superb skies, but the place that I've always loved going back to the most is Siding Spring in Australia, which is not the world's greatest astronomical site. It's not in a desert. It's in the middle of a eucalyptus forest. But you can come out of the telescope at dawn and you can watch kangaroos boxing with each other. And you can go down into the national park and have your sandwiches stolen by emus. And the sound of the currawongs in the eucalyptus, they're sort of crow-like birds that have a sort of call. I mean, it's hell when you're trying to get to sleep during the day, but I still have a great fondness for that place. The views of the landscape of ancient volcanic plugs adorned with eucalyptus is it's one of the most extraordinary landscapes on Earth. And
it sounds an amazing
I loved
place
going
to be,
back
yeah.
there. The last few years it hasn't been possible because there was a bad bushfire a few years ago which destroyed the observers' quarters, and for a while they've only been doing remote observing up there. But I hope to go back there and observe one day in the not too distant
fingers
future.
crossed you can return soon. Do you have a favourite season of the year?
Have they got seasons here? I thought it was always the same.
It's a bit monotonous in that it's wet.
I like the extremes. I like winter and I like summer. And I'm always sorry when each of them ends.
Oh. So to finish off the interview, could you answer this following question? And you can take some more time over it. What is the most important thing looking up at the skies can teach us?
It gives you a sense of impermanence and perspective. I can look up at the sky now and I see the sky looking exactly the same as it did when I was 10 years old. Everything that's happened to me has happened under the same stars. They're old friends. It teaches you that whatever stupidity humanity gets up to, there's a much bigger universe out there, and what we do doesn't really matter terribly much. But, you live out your life, and the stars don't care about it terribly much. But I think it also serves as a stern lesson. The other thing that happened early in my lifetime was the Apollo missions. And that first picture of the Earth from Apollo 8, I think, was a tremendous unifying influence on humanity. The first time that we could see that we were actually all riding on the same spaceship together. And so I think one of the most important lessons that just looking up at the stars can teach us is that we live in a very small place and we'd better look after it.
What a poignant and beautiful sentiment. That's a lovely place to finish. Well, Professor Andrew Cameron, thank you so much for joining us.
Thank you, Sam.
Wonderful.
You've been listening to Insight, the University of St Andrews Student Physics Society's podcast. I was your host, Samuel Lavery. Thanks to all the wonderful academics of St Andrews. Join us in the future as we learn more of the people making our education. This podcast was produced by myself and our publicity officer, Connor McBride. To find out more about the Physics Society and what we do, please find us on Facebook or Google St Andrews Physics Society for our website. Goodbye!